Lesson 4.5. Our learning target today is I can analyze a scatter plot. Our essential question says, how do you determine if there's a correlation between two variables? There are three different kinds of correlation that we're going to talk about. The first one is called positive correlation. That's when you see a pattern in the dots where they are rising from left to right. Positive correlation, I can draw a line of best fit through, and that line of best fit has a positive slope. So positive correlation has a positive slope. So that means that it's rising from left to right. Now, with positive correlation, when one variable increases, the other increases with it. So as x increases, y increases. Now, negative correlation is a pattern where the dots are decreasing. So it has negative correlation, has a negative slope. The scatter plot has dots that are falling from left to right. So as x increases, y decreases. So that's a negative relationship. One variable increases and the other one decreases. No correlation means there's not a relationship. There's no relationship between the variables. And you cannot draw a line of best fit when there's no correlation. So whatever the variables are, there's no relationship between them. No relationship between x and y. Now, line of best fit. I drew two lines of best fit to show you what they would look like. What a line of best fit is a line through the average or trend, the trend or pattern of the data points. So a line through the trend of the data. So trend as in like the pattern, and it has to be a line, like a straight line. It's not a dot to dot. So you're not connecting one dot to another. Your line of best fit might go through some of the dots on the scatter plot, but it doesn't have to. It doesn't have to go through any of them, but it's like an average line. So here's our y slide. Then you wrote equations given a point and a slope. Now you're going to investigate relationships between quantities by using points on a scatter plot. You're going to use lines of fit to make it evaluate predictions. Why? The graph shows the number of people from the United States who travel to other countries. The points do not all lie on the same line. However, you may be able to draw a line that is close to all of the points. That line would show a linear relationship between the year X and the number of travelers each year, Y. Generally, international travel has increased. So I could draw a line of best fit through these data points on the scatter plot, and then we could use my line to make predictions. Notice how I'm moving my line a little bit. If you don't feel like your line is going through the trend, you can always adjust it. Now, you don't have to be counting points on each side, but you do want to make sure that your line is balanced and that it looks like it's going through the trend of the data points. All right, first question, which scatter plot shows the most accurate line of best fit? Well, hopefully you can look at these and determine that it would be W. Because if you look at the lines for the other ones, one of them here has dots that are all up above. Another one has the dots all below. And then the last one has a line going straight across, and the dots are definitely not in a pattern that's horizontal going straight across. Okay, now we have the next three questions asking, does the scatter plot show correlation? If it does, draw a line of best fit and describe the meaning. So here's my line of best fit. Describing the meaning, looking at the labels on this graph, I would say that as time, so first off, I need to say it's positive correlation. I almost got ahead of myself. So positive correlation. And then the meaning, the more time you exercise, the longer you exercise, the more calories you burn. So the longer you exercise, the more calories you burn. Remember, with positive correlation, as one variable increases, so does the other one. Okay, so positive correlation there. Next one, definitely negative correlation here. So here's my line. Might want to move it over a little bit. There, that looks pretty good. So this one's definitely negative correlation. And what does it mean? If you look at the title and the axis labels, this one means that the heavier the weight is, the fewer repetitions you're able to do. So the heavier the weight, so as the weight increases, the fewer the reps. Fewer the reps you are able to do. Okay. So one positive, one negative. So that means this one, we are expecting no correlation. Definitely no correlation here. The dots are all spread out. So there's no correlation. So what does that mean? No relationship between, look at each axis, no relationship between the number of books borrowed and the fine. Think about when you borrow books at a library, you don't always get a fine. The fine is if you damage them or don't return them. Okay, now we're going to have a couple problems that are just asking us to interpret. So let's see, the graph shows the line of best fit for data collected on the amount of liquids consumed by a runner in relation to the distance he ran. Use the line of best fit to answer the following. What volume of liquids will the runner consume when he runs 7 miles? Okay, so here's 7 miles. If I go up to my line of best fit, so I'm showing you right here's my line of best fit. So I go up to the line of best fit. So I went up like this, and then now I need to go over. So it's between 9 and 12. So it looks to me like about 10 and a half. So maybe 10 to 11 fluid ounces would be a good estimate. All right, now the other one, if a runner consumed 15 ounces, so that's up here, how many miles did he run? So I'm going to do the same thing. So 15, I'm going over to my line. It looks like it's right here. So then if I go down, it looks to me like 10 miles. So make sure that you're looking at the line of best fit to answer the questions and not at the dots on the graph. Okay, now we have to make a scatter plot. Number of books and cost. Okay, so we have cost over here. Number of books. And we're going to have to answer some questions. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I can't go by ones. Twos. Okay, so 1 is 5, 3 is 8, 4, 11, 5, 11, okay, 7, 14, and 7, 17, 8, 18, and 9, 20. Okay, now if I draw a line of best fit through this, so we'll go with that for my estimate. Now I need to answer a couple of questions. So use your line to predict the cost for 6 books, and then how many could you buy for $10? Okay, so 6 books. So here's my 6 books right here. If I go up to my line, so I go up to my line like that, and then I go over. So to me, it looks like it's almost $14. So for 6 books, I could say my estimate, so I'm going to call this part A, my estimate is about $14. And then for part B, it said if you have $10, so now here's my $10. If I go over to my graph right here and go down, I'm going to say 4 books. Okay. So make a scatter plot, draw a line of best fit, and then answer the questions. Next one should be pretty quick. Rate of change is the slope of the line. So I'm going to pick 2 good points used. Looks good right here, looks good right here. Rise 5, run 8, 5 over 8 is D. Next one, rate of change. Looks good here, looks good here. Now, how many am I going up? If this is 20, this is 25. So 5, 10, 15. And then I'm going over by ones. So 1, 2, 3, 4. So 15 divided by 4. 4 times 3 would be 12. So 3 3/4. So B would be the correct answer this time. So just be careful and make sure you're looking at the scales each time. All right, now we've got a ski resort that kept track of the number of skiers and the temperatures on different days 1 week. Which of the following fits the data the best? Which of the following lines? The data is plotted below. Okay, here's the deal. This might look a little bit confusing to you. Here's your x-axis. Here's your y-axis. Okay? There. So now, looking at that line, it clearly has a positive slope. So I can get rid of this one and this one. And looking at that y-intercept, here's your y-intercept. It's clearly a positive, so I can get rid of that one. So that leaves me with A. So eliminate the ones that don't make sense. Positive sloping lines go up from left to right, so I eliminated the negative slopes. Then I eliminated the negative intercept, so that left me with only one equation that made sense. And that was our last example. So hopefully I've helped you to understand scatter plots, lines of best fit, and how you can analyze scatter plots.